Wait, what?
I said!
What is orthogonality?
Orthogonality is equality of two lines intersecting at right angle. In this figure, vectors A and B are orthogonal to each other. This is more of a math definition. Fundamentally, orthogonality is the property of mutual exclusivity between the objects of a set. Let's see an example. A herbivore eats only plants, whereas a carnivore munches only meat. So that would make both of them orthogonal to each other because they have mutually exclusive dining preferences. Let's see a bit more useful example now.
Orthogonality is a key concept in developing advanced aircraft flight controls. If you look at an older aircraft cockpit, it'll be full of many different controls for the different flaps, different ailerons, spoilers, slats, rudder, elevators, and also for throttling the engine. So using orthogonality, we may be able to reduce the number of controls required. For example, solely changing the aileron deflections will put your aircraft into a bank, and it'll allow you to turn. However, you will also get a reduced lift, so your altitude will decrease while performing this maneuver. But when you are turning, you likely want to maintain the same altitude. So you will also have to maybe perform or have elevator deflection to pitch up and increase your angle of attack. So you get more lift and maintain your same altitude. But what if we could change the basis for pilot inputs? This new basis will have to be composed of three orthogonal vectors, one controlling climb rate, one controlling turning, and one controlling the speed. This would make the pilot's job much easier, and this decoupling using the principle of orthogonality makes aircrafts much easier to fly and is the basis for developing autopilots, and the hope is that one day with further understanding of aircraft dynamics and aircraft control, you can make flying an airplane